thank you again, and thank you to Henrik for taking over yesterday, and that was excellent. I hope I can do it at least at this. Okay, one more coming. Kasper's coming. As good as you. Before we start today, there's some small changes to the agenda for today. Just quickly running through the agenda. I will do this short welcoming and then an introduction to GRA1 in general. Many of you, of course, knows about that, but there's also new people here today. And then we have Alberto Colmenero from Nordinet presenting some of the stuff from last year's architectural workshop here in Copenhagen. And I think you will also touch base on what you did in GRA1 in GN3. And then we are having two remote speakers. The first one is Panos from GRNet, and the second one is Aphrodite from GRNet as well. After that, coffee break, and then there is three presentations from the task leaders. They are more focusing on some of the case stories that we might work on later on. Then lunch at 12:30, and then we have a presentation again around clean slate architecture. And then we should have Alcatel Lucent, but they have sent their apologies. So to move quick on that one, I have convinced Miriam Usman to tell you the story about the upgrade of the Shank network and some of the services, and I will try later on today to convince Miriam to solve something more. Besides that, hopefully we can have a discussion around some of the services that can be used by the tasks. And then warm welcome to Shanna that has come here in person. That's really nice. And many of you already know Roland, been working for SurfNet in many years, for many years, so you know him. Then another remote presentation from Telefonica. Then coffee break, panel discussion. We are not completely set around the panel discussion, but I'm hoping that the task leaders and we can come up with some really good and interesting topics. But of course, it will be focused on this architectural workshop. And then at the end, just a quick introduction to the case stories for Friday. I'm just having a quick look at Friday's agenda. That's mainly devoted to work in groups. We have arranged for 3 groups. We have 3 meetings rooms, so that's the reason why. Where you will work on these case stories, and you'll have the honor of presenting your ideas at the end, and some kind of wrap up in the end as well. And we are aiming for having lunch at around 1 o'clock. Of course, you're free to leave if you have urgent flights or whatever. You're also free to stay here and work if you would like to do that. So around 1 o'clock tomorrow, we should hopefully be at the end. Any comments, any questions for the agenda before I kick on with the presentation of GRA1 in GN3+? Nope. Okay. So, a little bit about the background for GRA1. Many of you, of course, know this, but when working with GN3, we were at that point upgrading the network to the latest state-of-the-art transmission equipment, and we were also upgrading the IP infrastructure. I know that Miriam will tell you much more about that later on, so that's actually really nice that you can present, Miriam. That gave us a massive increase of the capacity in the network compared to the old network. Of course, there is still the same philosophy that has been used when building this network, And that's also one of the reasons why we came up with the idea of this clean slate initiative, to perhaps come up with new ideas for how to build networks. All of us knows that demands are increasing. Can this type of architecture survive in the future? Can it support the future when talking about cloud services, high-speed mobile networking, scientific content delivery networks, sensor networks, and of course also new emerging services that are coming up that we should also look into. I know that you do that already. So that's some of the background that somehow initiated the scope for GIA1 in GN3+. So the objective in GIA1 in GN3 was to make technology studies of different technologies, and I know that Alberto might touch base on that later on, what has been done, but there was no real focus on how to architecture a network. So that led to bring all this stuff that has been made in GIA1 third on to somehow support the community in how could we architecture networks. So in GN3+, GIA1 would come up with some kind of architectural proposal for Shank and Inwinds in general. So I know that this is not new stuff to many of you, but I guess it's good to be refreshed. So one of the tasks we're focusing on, or are focusing on cloud architectures. Another one is focusing on mobility architecture. And then of course we all have to look into novel types of architectures. And all this should somehow at the end provide us with some types of architectural design proposal ideas that can be used by Shank, but also by the community, and hopefully we can also inspire our suppliers or the supplier in general to come up with some of the, or support some of the ideas we are coming up with. And then of course the new part, the open calls, that I know that Paul mentioned it was very important that, yesterday he mentioned that it was very important that we somehow integrate their work already now into the different tasks and into the project, so they are not hanging out here in the air for the next 2 years and we will receive a deliverable that's nice and hopefully someone would read it. I can just ask you the question. I know that in GN3 GIA1 that was produced around 1,000 pages of paper. So any of you looked at that? Someone is nodding. What small nodding? But again, it's important that we somehow bring their deliverables and their ideas into the projects. And that's also one of the things that in GN3+ we are also trying to aim for a new way to disseminate, to bring out the message to the community, what you are working with. So it's not just paperwork. I know it's really high quality what you're producing, but it would be really nice if we really could see someone using it at the end. Or somehow it would be influence the community in general. Again, I mentioned the open call projects. I know that there has been presentations about that yesterday, but just quickly, I'll just show you the different calls that have been out, where the focus in general for GIA1 was the clean slate architecture, flexible optical network, multi-domain and optical modeling tool, and alien wave over Shank. And as I said, we didn't want to see this at the end just be a lot of paper that at the end was discarded. We wanted really to collaborate with the open call guys and girls, and so far I think it's very promising. I won't go into details. The ones here in blue is those open calls that also have some kind of relation to GIA1, and we are also looking into those open calls. Just quickly about the open calls, the clean slate architecture that was presented yesterday, Irina, looking into new ways how we could build the network. The focus here was very much on the upper layers, meaning layer 3 and layer 2. The winner of that proposal was IMINE's Watford Institute of Technology, Next Works from Italy, and I2CAD from Spain. I won't go into the details because I know that you will have a presentation later on. Flexible optical networks. Could we do something on the optical layer regarding bitrate, fit code, spectrum, modulation formats? Could that be done in another way? Could that be more flexible? Could the optical components become more flexible in order to support the future capacities like 200, 400 and terabit waves? The winner was Reaction. They gave a really nice presentation yesterday, and for those of you who haven't seen it, it can be streamed on the Nordnet webpage. The winner here was Cinet from Italy and UPC from Spain and Telefonica from Spain as well. And one of the really good things here is that we now have brought in the industry into this, and I also know that hopefully Sienna and other manufacturers of hardware will see that there are now opportunities to really be a part of the project and actually also receive funding for their research. Yes?
Coffee Project also, does Coffee Project participate in this flexible optical network open call?
Partly. So yes, would be the answer to that. Mohammad, nice presentation from Anna yesterday. No problem. There was a big relation here again with the alien wave part. Many of you knows that during GN3 we have been working a lot with alien waves, and some of the outputs there was that we needed some kind of modeling tool in order to support the operation of alien waves. So that was the outcome of that, leading to this open call, and the good thing is that I know that DTU and GWDG will do a spectacular work on that one. The alien wave part was not possible, I would say, or I would say that those that submitted the scores were not high enough. I also would say that they might have run into some problems, or it might have been very costly for the community to try to run alien waves on the Infinera platform, because there are some limitations there, but we won't go into details around that now. So how to achieve the objective? Well, of course, research network architectural designs better suited to a broader range of emergent services than the current architecture. I know that you're already working on all that, looking into papers, white papers, reports, and also what vendors are doing. The designs that are coming out, or the ideas that are coming out, can of course be some kind of amendments to how we built the structure architecture today, but it could also be some kind of clean slate architecture that we have really to go out and praise for, or something in between. And in order to reach that, well, there will be a lot of, you are doing a lot of desktop study, but there will also be a lot of testing and demonstration of the findings you are coming up with. And again, we are aiming to have yet another architectural workshop next year, and this time it will be together with Terina, and we will hopefully also be able to invite more activities and even more vendors to participate in this. And of course, as I also mentioned, test and demonstrations of the work that you are doing, also to support your dissemination of your results. And this is fine and nice, but hopefully you can support how we are going to upgrade or build the network in GN4 or whatever it will be called, and also hopefully influence some of the entrants in Europe or even in the world, I would say, because many entrants are looking to Europe for what we are doing. Deliverables, task 1 is, I used to call it the umbrella task, but it's there where we combine everything, because we cannot just build a cloud architecture or a mobility architecture. We have to build a common architecture that supports all of it. So somehow we should figure out how to incorporate all the findings and results into one type of deliverable, and of course also the outcomes of the open calls into this. So we can provide a complete set of architectural proposals, as I mentioned before, which can provide ideas for how to plan the network architecture towards Horizon 2020. The resultant findings will, as I said, be supported by test and demonstration. This is the interesting one. I mentioned it before here in my presentation, the quality reports, or whatever it would be, how you're going to present your findings and results. Just quickly, this is the usual or the traditional structure when presenting in general something about GN3+. So there is a relation with JRA1 towards SA1, the core backbone services, and test beds as a service. JRA2 and JRA3 are similar. But if we really dive into this, JRA1 is, of course, still supporting SA1, the test bed. I don't know how many of you are familiar with this test bed or pan-European test bed that are being built, but it's actually a test bed that should cover the entire European footprint, so you could just grab whatever you need without thinking about delivery time or cost or anything. An important one is the support of SA7. SA7 is looking into the cloud services and the mobility services, not that much into the architecture beneath, and that's where you guys are really going to support with your ideas. Of course, TRA2, in the beginning everything, especially regarding SDN, was focused there. So I guess you are all looking into something in relation to that, or even to control plane technologies in general. Sorry. So we also have to really collaborate with JRA2. And of course the community in general. We should not forget that there are 32 entrants out there that also have ideas. Not saying that we should bring them all into the pot, but we are trying to invite them to participate in the discussion, and also to participate in the workshops and other stuff that we are doing. Just a quick overview of TRA1. It says here 24 months. It's not confirmed yet, but it seems that, again, even though that you're working hard and producing a lot good quality, you're not spending all the resources. And there's also a gap for the next European frame program. So we are missing out on a year, meaning that we might extend it with an additional year. But it's not confirmed yet. But you, I would say, should expect that something like that would happen. Manpower right now is equal to 189 man-months. We are 16 partners and 2 subcontractors involved in this. And around 28 participants, plus minus a couple. Hopefully your logos is present here. If not, let me know. You know this guy, He's the task leader of Task 1, Future Network Architectures. So Henrik is sitting there. I won't mention all the names, but if you've forgotten, please let me know. And Damir Rekmart, sitting next to Henrik. And that's Network Architecture for Cloud Services, and they have come up with a really brilliant idea about this Open Cloud Exchange, which we are going to hear more about today. And I think that especially Sienna would find that interesting as well. Again, if I've forgotten you, please let me know, and I will make corrections after. Ramonas, he's over there today. Network architecture for aggregating high-speed mobile networking. And the team is, again, listed here. Paul van Dalen, sitting there, the coordinator for the open calls. Very important task for him, I would say, to bring the open calls into the project. So if there is anything, well, he mentioned that yesterday, just grab him and contact him, and I know that he will make sure that you get what you need and can set up the contacts and meetings, whatever. And very important as well, the Inga, doing all the really interesting work here in the project, and she's really doing a splendid job, and she has been hired to, Brian's not here today, to SA2 to do the same work, so that's nice. Then there's me at the bottom. Now I'm more or less relieved from everything, good task leaders, admin support, so now I can do something else. But so, questions? Wow, that's good. Or bad. Okay. I think the next speaker then is, if you don't have any questions, is Alberto Colmenero from Louridas. Du kører op med den. Skal jeg bruge den der? Jamen du, altså. Ja, du skal bruge den der.
Den her?
Ja, den er tæt. Hvad er den?
Nej.
Det er nemmere, for det skal stå der.
Ja, det er lige meget. So good morning, everybody. My name is Alberto Colmenero, and I work at Nordunet. And last year, and for the last 4 years, I was involved in GN3 project as well, but what is was called only GN3. And actually, I think a lot of people here have been working in the project with me. So what I'm going to do is we're going to do an intro about the last year's workshop, which was mainly about our part of the project, and then I'm gonna link what the come out of that workshop with the Prism project, which I will introduce later on. And so just for you to know, the Prism project is the name for the procurement project that Nordunet has been involved. And so I will talk about the technical requirements that we had for this procurement project, and I will show you how the future Nordunet network will look like. So short intro. This is my marketing slide, by the way. So just to give an idea why we think, especially Tony and Nordunet, why we think these workshops are needed and are necessary. So we have had how many? I think we had last year, but we had like a kickoff also like 3 years ago. We had it here, and we have this year's. And Terena, they started as well with architecture workshops like last year. They had last week one in Prague. So actually these workshops are really good for entrants to understand the needs. They actually is a good way for setting ideas and concerns. So last year we had Infinera, we had Siena, we had Alcatel-Lucent here. So it was a good way to get the latest view from them and what is going on in the provider world. So that's very needed, I think. And this year we have Siena as well. So it's a good way for start talking about the future. What are going to be our concerns in 5 years from now, and where are we going? So, like 3-4 years ago, we started hearing about cloud computing. It was not really the big thing, but now it seems to be the driver for future networks. So it's also about networking and collaboration, and finally, it's a good way for get an update about the GN3 projects and what's going on. Actually, this one is the main purpose, right? So that was the intro about this. So now about last year's workshop. So the main focus for last year's workshop was year 1, task 1 and task 2, which were different from year 1, task 1 and 2 in the GN3 Plus project. As Tony mentioned, we were more technology oriented in last year, and we actually did a study about different technologies, and they were presented in last year's workshop. So, and I think everybody who presented is here, more or less. So we had a presentation about the work done about OT and switching. So we tested Adva equipment, we tested Siena equipment in Atlanta. We tested Alcatel-Lucent equipment and all that. We gathered all that into a study that you can actually find out in the GN3 homepage. And Anna presented this work in last year's workshop. Then we talked about our Ethernet OEM studies during year 4, and also the last year of the first part of the project. We built a multi-domain, multi-vendor testing network where I don't remember, but I think 6-7 entrants were involved, and we did quite extensive testing about Ethernet OEM. And Victor Oliver, which is from Janet, did the presentation here. We also tested a protocol from the ITUT called Y1564 testing. This is this testing was done by Nordnet and Janet, and I don't know if you heard about this, but this is I think personally that this is very nice test protocol, and it allows you to verify the SLAs with your customers. So if you deliver Ethernet service with specific parameters, with this testing you can actually measure that you are delivering this to the customer. And I don't know if it's used. Anybody's using this in their? No? Victor, are you using it after the? No. But I think this is maybe something. Maybe the fact that we are not using is that we don't have very. Our customers are maybe very easygoing compared to commercial world. So I guess maybe in the commercial world it's used. I don't know. We also talked about MPLS-TP and Ethernet or MPLS. So here, Nordnet tested MPLS-TP with. We saw a demo at Atlanta with Siena, and we also tested with Alcatel-Lucent. And Marcin from PSNC tested Juniper and Cisco equipment together with CESNet. So very extensive testing, and you could also find reports about this in the GN3 homepage. We also talked about it, did quite a lot of testing with regards to control plane. And we actually here had a lab in Nordnet with control plane, and we're playing around. And all this information actually was very helpful for us. I will explain you later how all this fitted into the Prism project and how it helped us to decide what we wanted to do. We did quite a lot of testing with alien waves together with SurfNet, and that was part of the GRA1 Task 2, which Lars Lange was task leader. And then there were two projects, very interesting projects in the last part of the GN3 in year 4. One was the SDN and OpenFlow, and I think it was more focused in OpenFlow, right? So we had a presentation about the status of OpenFlow in the commercial world. It was a status from the vendors, as far as I remember. And I don't know how much is changed from that last year. It will be interesting to know if we've moved on or we're still in the same position more or less. And finally, we had a presentation from Henrik from DTU about time-sensitive transport. And so what Henrik did is take a good representation of technologies that are used in the NREN world, like OTN and Ethernet and so on, and he tested the delay of these technologies. And again, very, very interesting presentation and very nice work. So last year we also had, and now I will talk a little bit about, we had Sienna and Infinera and Alcatel-Lucent presenting. It was very interesting to hear their views. And the second day we had the user cases discussion. So this is something that I don't know if you're going to do it this year as well. Okay. So a bit feedback from what we got from the vendors. I like to mention this because then you could maybe compare to what they talk about this year. So you can see if there's something new or it's still the same thing. But last year they all talk. It was we need more capacity. Demands are growing, mainly because of cloud computing and video conferencing, streaming, so on. And so how do we get more capacity? One way is, yes, we need bigger pipes, but we also need to make our infrastructure more efficient. And there are new technologies and new ways of doing that. They also talk about convergence and integration of layers. And that's funny because in the last years they say, well, we need to get rid of some layers. We have too many layers and we are getting confused and we need integration. But funny enough, now they start talking, no, we need an optical layer, we need the IP layer on the top, and we need something, we need the glue in the middle. And that's why they all talk about OTN now. And so they have these very well-defined 3 layers, all with their own purpose, right? They also talk about coherent optics. This is the enabler for 100G. And they also talk about elastic optical networks, which the concept is that in new optical networks we need the flexibility for choosing maybe the modulation format or choosing maybe the spectrum, how wide the spectrum is. In that way, you can control the bandwidth of your signal, and depending on if you only need to reach 300 kilometers, then you can choose one thing or the other. If you need to get longer, then you can tune these parameters to get longer, but of course you will maybe get less bandwidth. So this is very interesting stuff, and there's a lot of studies also as a part of the GM3. We also talk about super channels. This concept, I don't know if Infinera was the first one mentioning it, but at least it's part of one of their equipments right now, where they combine several carriers to achieve a bigger bandwidth signal. So that's why Infinera today has the DGNX, which is able to provide a 500G super channel. So they also talk about that. They all talk about SDN, but I think it's more like a future thing, because when we saw the presentation from Johan about OpenFlow SDN, it seems that everything is happening at the layer 2, at the Ethernet layer, and no, I don't think, or I haven't seen SDN implementations in production for optical equipment. Maybe Sienna can help us today with that, but but they can see there is something that is needed, and they talk about it. So probably sometime in the future we will see that on optical equipment. And of course they talk about control plane, but this is something that is real today and is part of current networks. I don't know if, let's check the time. Okay. So now I'm going to talk how all this information from last year's workshop you help us for the procurement process that Nordonet was involved. So I'm going to talk about this, the PRISM project. This is how we call the procurement project. And the PRISM project was, I'm going to read just from this because it's easier, was a collaborative procurement for DWDM transmission equipment, part of the Dante's strategy, more for all. So the idea with this procurement is to help NRENs to be able to purchase optical transmission network to provide 100G. And Dante actually was the authority acting on behalf of the procurement team. So they were doing the procurement, and Nordonet was part of this, together with also Sunet was involved. And the process of this procurement resulted in the award of 4 framework agreements with 8-year term. I think I can say now the 4 vendors that are awarded are Siena, there are Alcatel-Lucent, there are Corian, previously Nokia Siemens, and Infinera. So the idea with this procurement and this framework is that actually all NRENs can benefit from that. So instead of being one single NREN going to procurement, we are actually a group of NRENs, which makes, especially from the commercial point of view, is very beneficial because we get a better deal at the end of the day. So, and as far as I know, there are already NRENs in the process of getting involved on this. So I think it's going to end up in a good deal for everybody. So what we did is we used Nordonet as an example, as a user case for this procurement. And so the final bits of this procurement were based on Nordonet requirements, which were divided in 3 areas, were the technical, the operational, and commercial. But I only going to talk about the technical requirements. So yeah, the other ones are, if you want me. So what Nordonet wanted with this network, we wanted to be able to deliver 100G services in current network infrastructure, fiber infrastructure. So meaning that we needed actually coherent reception. We also wanted maximum control of the optical spectrum. So we wanted to be able to measure optical parameters along the different fiber spans. So we want to know what is going on when there's something wrong in the network. Of course, we wanted a flexible and scalable network solution which evolves as we are getting more customers and more traffic in the network. And we also wanted OTN switching. I will explain. I have a slide explaining why OTN switching and why not other solutions. We also wanted protection and restoration for services under 100G. And why not 100G? The reason was that it was cost benefit, really, because in order to have 100G protection, you need to have a control plane available at the layer 0, which is a bit more expensive, and you need your optical nodes need to be directionless. And again, this increased the price of your network a lot. Okay, 5 minutes. And we wanted to have a control plane. We wanted to be able to continue supporting alien wave, so that was a big requirement for us because we are part of these initiatives in the NREN community, and we wanted to continue with that. We wanted a network that was future-proof, so meaning, just an example, for example, gridless, which is something that is coming. And of course, we had some physical and some power requirements that needed to be fulfilled. We needed proper design tools, because as the network evolves, we want to be in control of the design and not just leave everything to the vendors. Of course, we will ask them for help, but if we can, we would like to do it ourselves. And we wanted an advanced NMS to easy operations and so on. So that were, in general, our requirements. So the reason why we wanted OTN was that, of course, we had now, or we will have this 100G. We need something to groom the traffic, because most of the services we deliver today is 10G. So we needed something to groom the traffic, and that's what OTM is able to do. And we could have done that with a max bonder solution, but we thought that was not flexible enough, because then you will need point-to-point 100G with the max bonders, and every time you need another 10 gig between other two nodes, you have to deploy this max bonder solution. So the OTN switching gives you the possibility to switch services between any point in the network. The OTN provides a very good integration with the DWDM, with the layer 0. Everything, if you know the G709 standard from the ITU-T, explains how this is done. It has a transport alike. Well, it's OEN, operation and maintenance, and it has this feature called tandem connection monitoring. Allows you to provide monitoring across domains of the network. And I think, at least we think this could be very, very needed, especially when other entrants like Dante and I think SurfNet and I don't know, but I think there are other entrants there that are getting OTN. If we provide these services across these domains, we can actually monitor end-to-end these services, and that will be very helpful for the NOCs. We need a protection and restoration, of course, and another thing that OTN is good is it provides a base common framework across optical networks. So it has a very well-defined and standardized interfaces. So if you want to connect to the network that has OTN, usually it just works and you don't need too much troubleshooting. So that was the main reasons. And very shortly, why control plane? So mainly because we wanted to be able to do end-to-end provisioning of services, and because we wanted to have automated restoration. So that was the main two things. I know there are probably other advantages with having a control plane, but this is what we needed it for. And since I don't have so much time, I move forward a bit faster. So this is our current network. It's based in Alcatel-Lucent equipment, and today this is our IP core, and we had 40G. So what is, and this is how the new network is going to look like. So it's not big changes in terms of topology. We're going to get 2 more points of presence, one in Amsterdam, one in London. And we are in discussions with SANET. Since we have fiber infrastructure there that is common, we might also extend the network with SUNET, so we will have a few more POPs in Sweden, in the south of Sweden. But that's not defined yet. So this is more or less like it's going to be today. So with this network, so we're going to be able to provide 100G between any of these points of presence. I know Uninet is requesting one now, so that's good. And we will be able to provide 10G restorable services. So just short example, if we had a fiber break there, thanks to the control plane, we will be able to restore the traffic across the other link. Today we don't have any protection, so this will improve the quality of our services quite a lot.
How do you do with protection? You say that you have protection only on optical level and UTN level.
Yeah, that's the. Oh, sorry. So the 100G. So these nodes have an optical part and an OTN switch. The 100G only go through the optical part. But the 10G, they go through the switching, through the OTN switch. So you have a 10G in case there is a fiber break. The OTN switch has a control plane that is enabled to first, has a topology view of the network, so it knows if there is another available way, and then it signals the new services across the across.
Talking about the 10G here, not 100G.
Yeah, 10G. Only the 10G is restorable. The 100G won't be able. So if we
The line side is 100G.
The lines, also the client side.
Yeah, the client side is 10G and the line side is 100G.
Yeah.
And I talked about when the client side is also 100G, and you count.
in that case, it will be lost. Yeah.
Yeah.
There. Yeah. But the reason why is that most of the 100G services we deliver today is for example, for our IP backbone. Our IP backbone has the protection at the layer 3 level. So that's why we didn't need it for that reason. So what's going to happen next? So we are in the process of finalizing the contract with the vendor that we've chosen, by the way, Sienna. I don't know if I mentioned it. We have to define the deployment and migration project plans, and we are starting the process for that. And we have to build a lab, and that has to happen very soon. We are also next week. Some of our colleagues are going for training already for the new equipment. And the first links are going to be migrated in Q1 2014. And we expect to be finalized. I mean, the final plans are not ready, but the initial plan, our initial idea was to be finalized with the full migration by Q3 2014. So.
Thank you, Alberto.
Yeah, any questions? Yeah.
I guess your longest path is from Helsinki to London.
Sorry?
Longest path, longest.
Yeah.
Yeah. How far is it? What is the distance?
I need to check it out. Maybe you remember.
About 2,800 kilometers.
He's been doing playing.
2,800. Yeah.
He's been playing with the planning tool already. So
You can run it without regeneration. The plan.
That is one where we need regen actually.
You need
Yeah,
regeneration.
because there are some, especially between Sweden and Finland, there's some very long links between the islands that reduce the OSNR. So that's why regen is needed. Yeah.
Just one quick question. What about the old equipment, the Alberto? Did that use anything or just whatever, or would it just be jumping to the harbor?
Can we have? We can use it.
about the production equipment, I don't know what will happen. I think some equipment, yeah, probably for sale. But I think we'll keep something in the lab because it will be good for testing alien waves, for example, or for DTU. Everything has the right price. So.
Any more questions for Alberto?
Perhaps just a comment from vendor side on the Prism. So representing Chema here, representing the vendor industry, we see great value in having a framework contract. It's all about synergies. So the work that we've done now with Danse and Norginet as the initial project, everybody can hopefully leverage on that going forward. I know a lot of you have projects in the next year or coming years. You can really leverage that to the largest possible extent. Obviously, all projects are individual, but everything that's got to do with commercial, legal, a lot of the project-oriented stuff is already done. So it's a win-win for everybody in the industry. So that's why we went into this project.
Thank you, Sean.
Thank you.
Then we have a remote speaker, Panos. Can you hear us? That will just need your
Yeah.
mic. Hi, Panos, can you hear us? We cannot hear the sound. Just wait a second, Panos. Okay, try to say something. He jumped out. No, but no. He den der. Hvad vil du have? Den der. Præcis. Den der unmuted, er det?
Men det jeg mente var bare at ligge den der, så kan verden opfange
På
fjernsynet.
Nå, på fjernsynet. Hvad med den her?
Det er bare så stort, det der.
Det er et spørgsmål til bruger. Ja, den skal tændes hver gang. Hvis vi ikke kan. I think he's trying to reconnect, but the next presentation is Panos Louridas from GRNet, and after that Aphrodite, and I know that Aphrodite will be ready as well. I can see she's connected. So hopefully. Maybe I could invite someone to do a step dance up here while we're waiting. Anyone volunteer? Damir? No?
Bueno, sería copia, copia. Ahora
That seems like you, Aphrodite, typing something. Can you mute, please?
Yes, thank you. It's just that I would like to make clear that I do not, actually I'm not supposed to give a presentation for SA7. Actually SA7 wants to follow the procedures and to see how this is relevant to SA7, but do not have anything to present right now. So at least from the GRL point of view, it's Aphrodite only who will present, and I am here with my SA7 hat to act as a link between your activity at SA7 and to follow what you are doing. So perhaps I will come in with questions, etc., but I do not have a presentation right now.
Okay. Okay. Well, Aphrodite, if you can start your presentation, then you have sometimes extra. Now we're really messing up things. So Aphrodite, 3 connections. Aphrodite, can you hear us? Apparently not. Are you connected, Aphrodite? Good morning. This is interesting. Yes, I am. Okay, can you hear us? Yes. Okay, then we need a presentation. Can you share your... We need to unmute.
No, that's supposed to be
Hello?
Hello.
Okay. So you can hear me. Can you see me as well, or?
No.
Okay. Do you mind that you cannot see me? I mean, I will try now to share my screen with my presentation. So.
Just to inform
Okay.
you, our technician here is in dialogue with her, sitting in the big control room. This is a small control room.
Okay. Can you possibly see my screen now?
Yes. Oh, yeah.
Okay. But this is not the right presentation. So this is the right one. So because when you want me to start, Tony, let me know, okay?
Please start. Please start. The floor is yours.
Okay. Okay, I thought that was not up until 10 past 10, but...
That's true, but your colleague Panos has apparently misunderstood something, so there was nothing to present right now. So
Okay.
The floor is yours, Aphrodite.
Great. So good morning. Thank you for inviting Jerry to present in your meeting, and it's unfortunate that we could not be there in person. So I will take the next, let's say, 20 minutes to go through what Jerry2 is about and areas or parts of our work that could be relevant to Jerry1 and the work on network architecture that is taking place. So Jerry2 is dealing with a number of very recent developments in networking, following the SDN OpenFlow latest trends, standardization developments in ETSI, for example, the network functions virtualization concepts, the Open Grid Forum work on NSI, the TM Forum frameworks, and the network as a service, openness and network as a service concepts and developments in the NREN community. It is composed of 2 tasks, and one of them is about OpenFlow SDN, and the other one is about networks as a service, network virtualization, and NSI development. So I will not get into the details of this, the logistics, but the important thing is that this activity is split in 2 tasks. So going into Jerry2 task 1, OpenFlow SDN for specialized applications. The aim of this task is to do research on OpenFlow SDN to serve specialized applications, research and experimentation for our user community. How can OpenFlow SDN be used to deliver more advanced capabilities for our users? There are 3 main areas of research. One has to do with performance issues and enhanced monitoring capabilities for OpenFlow. As we know, OpenFlow in its infancy did not do much in terms of monitoring, but as the OpenFlow specifications are advancing, monitoring is becoming an issue. So we're looking into the monitoring aspects of OpenFlow SDN from 2 directions. One has to do with monitoring the performance of the OpenFlow protocol itself, convergence times and so on. And the other aspect has to do with enhancing monitoring for our infrastructures by utilizing OpenFlow capabilities. The other area of work has to do with multi-domain federated SDN to enable SDN offerings across the NRA and GN environments and globally. And the third area of work has to do with leveraging SDN technologies to deliver flow-based network services. So using what OpenFlow SDN, so the The former two had to do with enhancing or extending OpenFlow itself. This third one is about using OpenFlow to deliver flow-based network services in the area of clouds, in the area of security, and in the area of applications utilizing SDN for flow-based handling of their traffic. So if we get a little bit deeper into the performance issues and enhanced monitoring capabilities work that we do, we are working to merge the open source implementation of 802.1 that was done by the SurfNet Sarah groups into the Open vSwitch code. We are also working on how can we monitor OpenFlow network statistics counters defined by the protocol, and how can other protocols be used to monitor the OpenFlow network. We're looking into IPPM metrics in OpenFlow networks, and last but not least, in exposing the monitoring information that can be collected in the previous ways towards applications. For example, how can a controller in an OpenFlow domain expose monitoring information to an application to help the application make decisions about flow routing and so on. In the area of multi-domain SDN, the main concept is how to make two controllers of two adjacent or not SDN domains communicate to each other to create a multi-domain SDN controller data plane environment. There are different scenarios in a multi-domain SDN, cases where, for example, a bandwidth on demand domain, such as enabled domain, such as that of Jean, sits in between SDN domains. Cases where non-SDN domains, where two SDN domains are adjacent and we want to create an end-to-end flow space across them, or a case where an SDN domain is sharing the multi-domain path with no other SDN-enabled domains. And still we need to be able to deliver some end-to-end services. So, as usually with multi-domain SDN, we want to replicate the capabilities that exist in a single domain SDN environment. So we want to create slices, flow spaces for traffic flowing from A to B. And we're looking into how do we configure, how do we signal the SDN domains and the intermediate domains to implement those slices. We see a number of potential use cases for multi-domain SDN, for bandwidth on demand support. For some of us, bandwidth SDN is a very valuable last mile implementation candidate for bandwidth on demand. So we think that by using SDN, we can extend bandwidth on demand services into the campuses, for example. Another use case for multi-domain SDN lies in the area of multi-domain testbed. So we're already discussing, and we're in progress in Jerry 2 about extending the existing Giant OpenFlow facility with testbeds and resources in other areas in Europe and the US. So eventually, when the physical infrastructure is in place, we will need to be able to control and interconnect these multi-domain testbeds, and of course for cloud support across multiple domains, for distributed data centers or data centers that want to use SDN to exchange resources or swap resources among each other. In the area of security enhancements, a few more words than the initial ones. We are looking into how can the network flow analysis and control be used to enhance security in the network. How can what SDN do for us be used to enhance security features? So, we think that SDN can help by, for example, redirecting flows in the case of a security breach. So we're looking at how can we notify controllers about the security-related issues and how can they make decisions on flow routing. How to use OpenFlow to duplicate and forward the traffic to security appliances so that they can be scanned and cleaned. And of course, how to program the controllers to survive attacks. So although OpenFlow itself was not created with its primary goal to solve network security problems, we see that a lot of its features can be very helpful in some of these areas. And we're also looking into the concept. This is a more researchy part of our work. I think someone was joining the call but was not muted, but now it's okay. So we're looking in the area of, we've defined the concept of SDN apps. We are looking into the investigation of architectures and interfaces through which the SDN control plane can expose information or network functionality to the application and service layer. For example, if we have an SLA manager or a storage on demand service or another application that has to do with managing the network capabilities, how can the controller, the SDN controller, and specific functionalities on top of that be exposed to applications and can be used by applications? This is more on the conceptual and research side of things as we speak, but we believe there is value in this part of our work. Last but not least, we're doing SDN technology testing, OpenFlow hardware assessment of SDN OpenFlow tools, and can provide feedback and do testing to other tasks and activities within the project if requested. In summary, GRE2 Task 1 is not delivering a service. It is identifying SDN-related use cases relevant for GIAN and NRENs. It is proposing solutions by extending existing tools to support identified use cases, and it is providing building blocks in terms of design, architecture, but also prototyping that may be used to create new SDN-based services. So moving forward to the second part of the GRE2, the second task of GRE2, the network as a service, a few words about the rationale and motivation. The reason behind this work has to do with the need to decouple network service management from network infrastructure without reinventing the wheel. So, there is a big hype of virtualization and network functions and software-defined networks these days, but in essence, what network as a service is doing, based on a lot of previous works from our community, is to create the framework where this decoupling and this abstraction and virtualization, not only of the resources themselves, but also of the functionality and the network services management, can be, abstracted and become homogeneous. So the eventual goal is service delivery, but the aim of our work in GRE2 is to discuss and deliver on potential solutions that this can bring to existing service limitations in our multi-domain environment. And this will become a lot more concrete through the next slides. Here is a snapshot of the ecosystem today. So we have SDN, we have NAS, we have NFV. Each one of them has its own merit and value and position, but this slide here shows how they are, let's say, interrelated and interacting to complement towards the direction to which our networks seem to be heading to. So SDN allows for data for the control plane, software programmability, and it's an enabler for some of the network as a service requirements. Network as a service is providing the means to abstract SDN and other capabilities towards the end user, to implement the right delegation, who can do what upon the network. And NFV is, let's say, the vendor's view on converging infrastructures, homogeneous device interfacing, and virtualization. So the three of them, we believe in GRE2, and we work with all three of them to deliver our advanced capabilities. So a little bit more on the concept of NAS, network as a service. It's a service delivery model, and it is abstracting and homogenizing network services and capabilities. It enables multi-tenancy. It enables flexible deployment and operation. of a number of different network services and management capabilities. And it is abstracting the operational model and aims to increase the easiness in services deployment. What are the base features? NAS is abstracting and virtualizing service and infrastructure management capabilities. It is utilizing virtualization capabilities in the hardware and in the management and control plane, network virtualization functions as they're currently being shaped up by the industry, information models, semantic description models, resource and capability models. It also allows for multi-tenancy, role specifications. It can be used to model roles for use case stakeholders, users, operators, and so on. It enables the capability to offer customized interfaces to end users by deploying their applications on top of a NAS deployment. And it ensures right delegation, policy engines, security subsystems, management as a service for operations in multi-domain environments. So it is, let's say, in some ways, it is complementing the work that we see Jerry One doing in defining the network architectures in devising this layer on top of the capabilities of the actual hardware and the architecture of our future networks, with the user perceived operations perceived capabilities and add-ons like multi-tenancy delegation operations that are needed to deliver end user services. NAS is also can provide application support, automation, workflow and lifecycle management for applications, and of course support cloud services as part of this application support. And it also makes service deployment easy. It is based on principles and technology apart from adding other functionalities like integration with other services in the NREN community. So in many cases, some of the issues that have to do with the multi-domain services as we implement and deliver them today can be addressed by NAS efficiently. We're because the concept and the value of NAS is in many cases difficult to distinguish. We follow a use case driven approach, so we're very serious about defining use cases and service requirements which have a wide applicability to the GEN and NREN user community. So we're working on NAS, but not from a theoretical high-level point of view. We're working with concrete cases, and we want to make sure, and we're trying to make sure that these use cases of NAS have applicability in the GEN and NREN multi-domain environment. And where and if needed, we will be specifying and implementing existing the OpenNAS existing implementation. We will be implementing extensions for the specific use cases that we're looking into. And of course, we will be doing proof of concept based validation for these implementations and the specific cases that we're working on. So what are the use cases that we're looking for in the GEN environment? We're currently looking at 4 of them. It's the virtual CP, a data center use case, provisioning use case, the IP network overlay, and the network on demand. So you can see them in 4 different colors, and you can see the initials of these use cases, but I'll go into more details about them in a minute. The important thing is to show how each one of these cases is covering a wider part of the spectrum of the end-to-end service model provisioning that we have in GEN. So the virtual CP is touching the customer and the NREN area. The IP network overlay is not touching the last mile, but is relevant to the multi-domain intermediate networks. NREN giant regional networks. Network on demand is expanding all the way from the end user to the other end of reaching a computing infrastructure, for example. And the data center use case is addressing the area of data center functionality and capabilities. So we think it's a good mix of use cases that we're looking into here. Well, I mean, a few more words on each one of these use cases for which we think network as a service has a value. We're looking into the virtual CPE case because we have seen that in many cases NRENs do not have the proper access and control over the CPE they deliver to the customers in terms of configuration and monitoring. And even if they do, the setup is not flexible enough to be adapted to varying service context conditions upon user needs. So the stakeholders for the virtual CPE case are the NRENs and their customers and users. And the goal is to remove the necessity for a separate physical device at the CPE case, define a layer 2 demarcation point, and pertain the flexibility of the service that is needed toward the client, and delegate partially or fully the virtual CPE control to the user, so that the customer will no longer depend on its provider, the NREN, for CPE configuration purposes. And this is, let's say, a logical diagram on how can this be done. So you can see here that we're virtualizing the CPE, we're implementing a REST API for it. You can see on the left-hand side what can the customer configure on the virtual CPE, and on the right-hand side what can the NREN configure on the CPE. You know, it's one of the pieces of the work that we do that is inheriting a lot from the OpenNAS developments previously to the start of the Gen3 Plus projects and activities from NRENs like HNet. It's quite mature, and we're extending this work within GR2 Task 2. Then we have the use case of network on demand. Usually, experimenters in our community that want to experiment with a network infrastructure have to limit themselves to single domain testbeds, and they have no rights to manage the facilities provided. So again, here, either in the NREN level or at the NREN customer user level, we want to provide users with the ability to set up specialized network environment. Comprising of several domains with dedicated subnetting space, isolated from the rest of the normal traffic, and we want to use NAS to make this a service so that connectivity access ports addressing and routing functions can be allocated efficiently for these networks on demand. In the use case of IP network overlay, it's the usual problems of wanting to deliver to our user communities layer 3 services, and usually different kinds of aspects of delivering that become quite tedious for and you know, take a long time. There are also security aspects at the edges of such configurations. So in all the cases where a layer 3 network overlay on top of our infrastructures is needed, in many cases, Giant, for example, as a backbone in Europe, has been asked for very large projects to deliver this layer 3 network overlay. So the stakeholders are the backbone network providers, and the goals here are to be able to efficiently deliver multiple layer 3 networks to independent services and user groups. And use case number 4, data center administration. This is actually, I mean, a use case that came into our agenda recently by a real data center management group. They had a number of problems, for example, a multi-vendor site for which they had to implement configurations and a complex set of operational and configuration tasks, which was, troubling them. So here the stakeholders are the NRENs, who are eventually interconnecting these data centers, and the data center and networks operation center administrators of these infrastructures. So the goal here is to build a unified overlaid interface for physical device configuration purposes, and follow a generic approach to configure certain parameters using a kind of a template. Again, this use case is not as advanced as the others, some of the others, and is in its first steps, but there's useful and interesting observations already. So this was very quickly. I hope it was not too much what Jerry too is working on these days. So I'll be very happy to answer to questions.
Thank you, Aphrodite. I will ask the audience if there is any questions for Aphrodite. There's one. It's okay.
Hi, Aphrodite. I have some questions relating to SDN and OpenFlow.
Yes, hello.
Okay, we're talking about OpenFlow for monitoring, right? In the network, but I know that in BOD, Autobahn is transitioned to this NSI protocols, and they maybe have some monitoring issues as well. Are you considering the OpenFlow monitoring with the NSI monitoring stuff? Maybe they could work together, or I don't know.
Okay. Yeah. I mean, I don't see any immediate conflicts at the moment, because we're, as I said before, there are two areas in can you hear me okay now? Okay. So there are two areas of work that we're doing currently in GRI2. One has to do with looking at the OpenFlow specification, inherent monitoring. So what does the OpenFlow specification itself foresee or include about monitoring of the controller operations and so on? So it's totally internal to how OpenFlow works. And the other part of work has to do with monitoring, again, using other protocols like SNMP to monitor the performance of how the OpenFlow, let's say, components work within an operational environment. And the part about adding to the Open vSwitch software Ethernet OEM monitoring capabilities. None of these three parts, overlaps with NSI monitoring. What would be interesting is to see if we have a multi-domain case of OpenFlow domains and domains that are non-OpenFlow SDN enabled, but they are, NSI compliant. And if we, in that multi-domain case, we were thinking of establishing, let's say, an end-to-end circuit or end-to-end flow space, how would the monitoring along this end-to-end path be, let's say, implemented by combining metrics from the different domains? And that would be a very interesting and still very complex scenario. So this is where I think there could be some synergy. But as I said earlier, we are still in the process of defining how the data plane engineering should be implemented to do this, to set up this environment where SDN and NSI domains would live together. And we have not gone as far as, monitoring such an end-to-end setup. But you're right. I mean, at some point in time, when we sort out the data plane, let's say, and controller to controller in signaling, monitoring across NSI and SDN domains would be an interesting thing to look at.
Okay, thank you. We're sorry about this noise here. I have another questions.
Okay, last one.
Okay. Oh, okay. You're talking about SDN app. Is that OpenFlow as well?
Well, actually, both the term and the concept is something that the team has come up with. Let's say, it is a concept of formalizing the north-down interface of an SDN OpenFlow enabled domain towards application. So it is touching SDN OpenFlow, but it's not core to the SDN OpenFlow, concept and specifications.
Yeah, because it's related to the northbound API. So, are you into any standardization group like Floodlight or Open Daylight or?
Yes, very good. I did not mention that we are following Open Daylight, and we're following the developments in the Floodlight development. Unfortunately, we're also following NFV. We're also following the IRTF SDN research group. So, as part of our work in GRA2, we do follow some of the standard bodies in the area. We're a very small group, and we're not yet, I hope, actively involved. But seeing that as long as our SDN apps concept or ideas become more concrete and stable, we might have the chance to step up in some of these bodies and maybe have a more lively presence. But we are following what's happening there.
Okay, thanks.
Okay, thank you, Aphrodite. Any more questions before? One more question here.
Hello, this is Jeroen Valke from Belnet. You talked about IP overlays in your presentation. Now when I hear this, I spontaneously think about IP VPN, layer 3 VPNs. Could you perhaps, how do they relate? How do they overlap? Is there a relation? Just your thoughts on that, please.
I'm quite sure she can't hear because that's the phone the mic we just moved that. Yeah. This one is only for streaming. You cannot use that one.
She's also not anymore online.
I think she's. Aphrodite, you still there?
Yes, I'm still there. I think I have successfully stopped sharing my screen with you. Have I not?
But you didn't hear the question. Good. We have some mic problems. You just speak to that one. Another question.
Hi, can you hear me?
Yes.
Hello, this is Jeroen Valke from Belnet. You talked about IP or layer 3 overlays in your network. And I was just wondering how this would relate to, I would spontaneously think of IP VPNs, layer 3 VPNs. So what's the relation with that technology and what are your thoughts on that?
Yeah, the technologies are more or less the same. The slides I showed today, because we had a very limited amount of time, was a subset of one of the presentations on GRA222 in the symposium in October. So, in essence, can you hear me?
Yeah.
Okay, so in essence, the multi-point VPN, for example, service that is being currently under specification in SA3 is one of the applications of this layer 3 network overlay concept use case of the network as a service that we're looking in GRA to T2. So they're essentially, this is one of the cases of delivering IP overlays. But what we want, the important is that what we want to do is to, let's say, formalize or abstract the workflow that, for example, the multi-point VPN service is specifying as we speak, and the capabilities, so that they are in some way, let's say, homogeneous and universally applied and accepted by all the participating domains under the network as a service concept. So the technologies are the data plane are more or less what we're already using. What we're missing is the multi-tenancy, role delegation, modeling for provisioning and delivering these services, the northbound interfaces to applications for them to be able to signal such services and so on.
Thank you, Aphrodite, and sorry for the noise. We have some construction work downstairs. So, but anyway, thank you for your presentation, and I don't think there is any more questions. So, thank you, Aphrodite, for joining.
Thank you.
Okay, talk to you soon. Bye.
Bye.
Okay, I think it's time for the coffee break. And sorry for the construction work. I just talked to them and gave them our schedule. So unfortunately, I started 5 minutes before our coffee break.